In this video, we're going to be looking at some commonly used angles that we see over and over and over again in trigonometry and calculus. So those angles are 30 and 45 and 60 degrees. Now this particular table right here, which lists the sine of each of those angles, the cosine, the tangent, cosecant, secant, cotangent, again for all three of these angles, is something that may be worth memorizing to you. So if you know that you're going to continue on into pre-calculus and calculus and maybe beyond, these are values that you need to be able to call up in a hurry. Now if you're someone who memorizes lists and memorizes tables, then this is something that you can memorize. Now I'm not necessarily a memorization person when it comes to this, but I know a couple of tricks that help me remember these particular values. Now you could always type into your calculator and find the sine of 45 degrees. The problem is your calculator is going to give you a decimal. Same thing if you type in the sine of 60 degrees or the cosine of 30 degrees. Now some of them you might get lucky because some of them are nice fractions, like the sine of 30 is 1/2, the tangent of 45 is 1, but most of the time we're going to have decimal values which aren't going to be very useful for us. We would like more exact values. That's what we have here. These are exact values written as radical expressions. So what I want to do is kind of talk about where they come from and then my tricks for remembering them. So first of all, I want to focus on the 45-degree angle. If I'm looking at a 45-degree angle, I know that the sine of 45 degrees is the square root of 2 over 2. The cosine of 45 is also square root of 2 over 2. Tangent of 45 is 1. And then remember, cosecant, secant, and cotangent are the reciprocals of each of those. So the reciprocal of the square root of 2 over 2 is just the square root of 2. Same for secant because that's reciprocal of cosine. And cotangent is 1 because that's a reciprocal of 1, which was the tangent of 45. Now, why does that work the way that it does? Well, if I have a 45-degree angle, like this one, and I'm working with a right triangle, I know the other angle also has to be 45 degrees, which means that the two legs of my right triangle must be equal to each other. Now, in this particular example, we just gave them a length of 1. Now, if I have a length of 1, well, then the hypotenuse has to be, according to the Pythagorean theorem, 1 squared plus 1 squared, well that's 2, and then it's the square root of that, so that's why the square root of 2 is what I see for my hypotenuse. Then if I were to find the sine of each of those, well the sine of this 45 would be the opposite side, which is 1 over the square root of 2. Well, 1 over the square root of 2, I need to simplify that, so I multiply by the square root of 2 over the square root of 2, turns into the square root of 2 over 2, which is the value you see there. Right. Now I know that this holds true for any triangle that's got two 45-degree angles and a right angle, because no matter what the lengths of sides are, again I just picked a 1 and put it there. Well, if I had a similar triangle, 45 degrees up here, it's a right triangle. Let's say that this side length was 5 and this side length was 5. It would have to be, they always have to be the same. Well, then my opposite, or my hypotenuse would be 5 squared plus 5 squared equals c squared. Well, that's 25 plus 25, that's 50. So 50 equals c squared. Well, if I take the square root of that to actually find the hypotenuse, I get the square root of 50, which happens to be 5 times the square root of 2. Well, look at that, 5 times the square root of 2. So when I go ahead and find my ratios for sine, cosine, etc., I want the sine of 45 degrees according to this triangle. That's going to be 5 over 5 times the square root of 2. And guess what? Those 5's cancel, turn into 1's. All of a sudden I have the same expression I did here. 1 over the square root of 2 turns into the square root of 2 over 2. Okay? That's going to be true for sine, cosine. Tangent of 45 degrees is always going to be 1 because when I do the opposite over the adjacent, 5 over 5 is 1. 1 over 1 is 1. 10 over 10 is 1, etc. It doesn't really matter. If it's 45 degrees, its tangent will be 1 because the opposite and the adjacent sides must equal each other. So there's one little way to think about 45-degree angles. Now with 30 and 60, 30 and 60 are complementary angles within a right triangle because they add up to 90 degrees. So if I have a 30, 60, 90 right triangle, there's certain values that are always going to exist. I know that the short side, the side that's opposite the 30-degree angle, is always going to be half of the hypotenuse. Okay? And then the other side, the medium side I guess you could say, is always going to be the short side times the square root of 3. Okay? Now that being the case, again I'll show you an example where the number's a little bit different, but if I were to find the sine of 30 then, the sine of 30 would equal the opposite side, which is 1, over the hypotenuse, which is 2. So 1/2 is the sine of 30. when I find the sine of 60 degrees. Now I'm down here at 60 degrees. My opposite side is the square root of 3 over the hypotenuse, which is 2, so we get the square root of 3 over 2. Now when I do the other way, with a cosine of 30 degrees, well, the cosine of 30 degrees is the adjacent side, square root of 3, over the hypotenuse, which is 2. Now notice that's the exact same thing as the sine of 60. So the sine of 60 and the cosine of 30 happen to be the same thing, and the sine of 30 and the cosine of 60 are also the same thing. Again, because I'm talking about the same sides, just looking at them from a different angle. Now again, to show you something, if my numbers are a little bit different, maybe I have a 30, 60, 90 right triangle. Here's my 60 degrees, here's my 30 degrees. Let's say my short side was 5, for instance. Well, that means the hypotenuse would be twice that, so the hypotenuse would be 10. And then my other leg is always going to be the short side times the square root of 3. Now again, putting these together, finding each of these angles. Well, if I want, let's say, the sine of 30 degrees, that's going to equal the opposite side, which is 5, over the hypotenuse, which is always twice that length. Well, 5/10 simplifies down to 1/2. And the same thing if I wanted the cosine of 30 then, I'd be taking 5 times the square root of 3 over 10. 5 over 10 turns into 1/2, so I get the square root of 3 over 2. And again, it doesn't matter if it's 30, 60, 90, these are the values that are always going to show up. Okay? Now, ways to remember these, and again, these are values that we need to get used to seeing. We need to be comfortable with pulling up these particular values. A trick that I've learned actually fairly recently is the hand method. So let me show you how this works. If I need to remember the values of sine, especially we'll start with sine. What I'm going to do is I'm going to look at my hand. Now typically when you look at your hand, you're going to look at it like this, with your left hand right in front of you. So I'm going to go backwards for the camera here, and I got my nice big hand on the board. Now, what this is...
Ryan, Mary, Levi, Pimentel, and Jocelyn
Take a time
Mendoza,
out.
please come to the office.